Hi everyone, welcome back. So today we're going to finish off with the test 2 revision. So last time we got through questions 1, 2, and 3. We just have question 4 to go through, and then that finishes everything off. Okay, so remember this practice test 2 is going to be set, it has the same setting out as your real test 2 that you're going to have on Wednesday. So finding the area between curves, finding volume using disk or washer method, finding volume using the shell method, finding the average value of a function, and finally integration by parts. So exactly the same setting out. Okay, so let's finish off that practice paper. And then if you have any extra questions, please let me know as well. Then we can get through those. Okay, so question 4 from the practice test. Okay, so 4.1, we need to integrate the following function, x cos 3x dx. Okay, so again, we see that we have a product of two functions. So if we can't do a u substitution, the next thing we look for is integration by parts. Now, just looking at this, we can't do any u substitution. That's not going to help us. So we need to do a integration by parts. So one of these parts, we're going to have to differentiate. The other part, we're going to have to integrate. Now, if we differentiate x, we're just going to get 1. So that makes it simpler. If we differentiate cos, we're going to get sine. That doesn't get any simpler. So we choose x to be u, which means everything else is going to then be dv. So u is equal to x, and dv is everything else. Okay, now that we've made our choice of u and dv, we now need to find du and v. So du is going to be dx. And if we integrate dv, we have v is equal to 1/3 sine 3x. Okay, good. So that's all the pre-working done. Now we just need to substitute into our integration by parts formula. Remember how that went? The integral of u dv is uv minus the integral of v du. Okay, that was from way back. So we just substitute in. So u dv, that is our original integral that we want to work out. X cos 3x dx is equal to u times v. That's going to be 1/3 x sine 3x minus the integral of v du. That's going to be 1/3 sine 3x dx. Okay, so now we just have to integrate this. Okay, but that is nice and simple. We can do that very easily. So what is that integral? Okay, well, we have everything else stays the same. The integral of sine is going to be cosine, but remember that there's a minus. So it's minus cosine. Then we have to divide by 3. So we're going to end up with plus 1/9 cosine 3x. And this is an indefinite integral, so we have to have plus c. Okay. Any questions about this? Okay, not too bad. Let's take a look at the next one then.
Sir,
yes. Yeah.
how did you get 1/9 for cos 3x?
Okay, sure. So let's put a little star here. 1/3 the integral of sine 3x. How do we do that? Well, the 1/3 stays out. The integral of sine is minus cosine. But remember, we've got the 3 here. We need to divide by that. So it's minus 1/3 cos 3x. And then this becomes minus 1/9 cos 3x. Okay, and then the the minus and the minus, that now becomes a plus over here. Okay, does that answer your question?
Yes, thank you.
Okay, awesome. Another person asking here, how did you get 1/3? That is because we've got cos 3x over here. So let me just put this in red. Remember, when you're integrating cos of, let's say, kx, then this becomes 1/k sine kx plus c. And if you're integrating sine kx, this is going to be 1/k, sorry, minus 1/k cos kx, and then plus c. So whenever you have a multiple of a constant here, you need to divide by it. Okay, so the k in front of the x becomes 1/k, like that. So remember, when you're differentiating something like this, so let's say you're differentiating cos 2x, you know, the 2 comes in front, but when you're integrating, you need to divide by it. It's always the opposite. So if you have cos kx, it becomes 1/k sine kx. Okay, you divide by that constant. Okay, any other questions? Got another one here. Thank you. Okay, cool. Let's take a look at the next one. Okay, so the next one is 4.2. So this is the integral of x natural log of x dx. Okay. So now, again, we need to pick. One of these parts is going to be u. One of these parts is going to be dv. Now, if we pick u to be x, okay, then the derivative of u gets simpler. That's fine. But then how do we integrate the natural log? Okay, that's a bit more complicated. However, if we let u be the natural log of x, then the derivative becomes 1/x, okay, which is much simpler than the natural log. So you always need to think of both options when you're picking u and dv. Okay, so don't just go with the easy option of saying u equals x, because integrating the natural log might be complicated. So you always have to look at both options before you make the pick. So in this case, we made our pick. Let's swap the colors, sorry. So the natural log, we're going to make u, and the rest of it, we're going to make dv. Okay, right, we went through that thinking there. So u is going to be the natural log of x, because when we differentiate the natural log, it gets simpler. And then dv is going to be x dx. Okay, that's easy enough to do. So what is du? Du is going to be 1/x dx. Then we integrate and integrate. V is going to become 1/2 x squared. Okay, so that is all of our pre-working done. What we need to do now is substitute into our integration by parts formula. So the integral of u dv is uv minus the integral v du. Okay, I'm sure everyone has memorized this by now. We've done it so much now. Okay, so let's substitute in. So u dv, that is going to be the original integral that we're trying to work out. So that was the integral of x log x dx. Okay, that's what we're trying to work out. Now, u times v is going to be 1/2 x squared natural log of x, just multiplying those two, minus the integral of v du. So that's 1/2 x squared. That's the v part. The du part is 1/x dx. So this is the v part. This is the du part. So we just substitute that in. Okay, we can simplify that though. So this is going to be 1/2 x squared natural log of x minus 1/2 the integral x squared divided by x is just going to be x dx. Okay, so that's easy enough to integrate. So we're going to have 1/2 x squared natural log of x minus, now when we integrate x, we're going to have 1/2 x squared. So it's going to be 1/2 times 1/2 x squared. So we have 1/4 x squared. And don't forget your plus c. Okay, so another one, but not too bad. All right, any questions on this one? Okay, not too bad. Now, remember here for this part, big exclamation mark. Always check both options. Sorry. Always check both options in your head before picking. So in this case, if you just say u is equal to x and dv equals natural log of x, it's doable, but then you're going to have to integrate the natural log of x. And that's extra work that you don't need to do. But if we do it the other way, and we say u is the natural log of x and dv is x dx, you see how much easier it is. Okay, so just keep that in mind. Check both options in your head. So just quickly do the derivative in your head to see which one is easier for you. Okay, because maybe if you pick the other option, that's a lot more work for you to do. Okay, and that's for 2 marks, just in case you're wondering, between 2 and 4. So either 1 mark for u and dv, or 2 marks for u and dv. Okay, depending on the problem. Okay, but are there any questions about this one? Okay, so not too bad. Okay, so you should expect something like this for your test. Okay, remember it's one question on integration by parts. So you're going to have integration by parts, maybe a u substitution with it, a little mix of things. Altogether, it's out of 10. Okay, so you got 1 question on that. Okay, but remember, please show all your working. It's worth 10 marks. If you do it in 3 lines and you leave stuff out, or you write it on another piece of paper and don't scan it, I can't give you those marks. I need to see your method so that I can put the ticks down, right? Because there's ticks for specific things. If you don't show all your working, or you leave out the u substitution, I can't mark that. Okay, so please show everything. Even if you think it's not important, please put it down anyway. Okay, next one, 4.3. That's right. 4.3. Okay, so we have the integral of cos x, natural log of sine x dx. Okay, this one's a bit more complicated, okay, but not too bad. Same idea as we did before. You need to pick something to be u, you need to pick something to be dv. Now, this looks a bit more complicated. What do I pick? But notice that we have the natural log of something. Now, remember, it doesn't matter if it's the natural log of x, or if it's the natural log of x squared, or the natural log of sine x. The main thing is that it's the natural log of something. Whenever you take the derivative of the natural log, it gets simpler, because it goes from being the natural log to being 1 over the inside part. Okay, so it's always simpler to differentiate the natural log of x than it is to integrate the natural log of x. Okay, so no matter what you're getting, it's always simpler to differentiate that. So that tells us u is the natural log of sine x. And of course, if you do all the tutorials and the homework, you'll see that in most cases, this is the best pick to make. Yeah, so it just comes from experience. You'll see after doing lots and lots of problems, you'll see constantly, if you make this pick, it makes your life a lot easier. Okay, of course, you could try it the other way, but you're going to have a lot more work to do. Yeah, but that just comes with practice to see what, what pick to make. Okay, but this is the pick that we're going to do. U is the natural log of sine x, and dv is going to be the rest of it. So cos x dx. Okay, now that we've made our pick, we need to differentiate u, we need to integrate dv. So du is going to be, now we need to use the chain rule because it's the natural log of the sine of x. So we have that composition. So first, with the chain rule, it's going to be 1 over the inside part. So 1 over sine x. Then we need to differentiate sine x. The derivative of sine x is cos x. And then we need the dx. So this is the chain rule. Okay, next we need to integrate dv to get v. That's easy to do, that's just sine x. Okay, so we've got everything we need. We've got u, we've got dv, we've got du, and we've got v. Now we just need our formula. So that is the integral of u dv is equal to uv minus the integral v du. And we've got everything we need to substitute. So the integral of u dv, that's what we started with. That was cos x, the natural log of sine x dx. Okay, that's the thing we're trying to find. U times v. So u times v is going to be sine x, the natural log of sine x. Okay, minus the integral of v du. So that's going to be sine x times cos x over sine x dx. Okay, but that's really nice because we see that the sine x in the numerator cancels with the sine x in the denominator. Okay, we've got a nice cancellation there. So this is going to give us sine x, the natural log of sine x, minus the integral of just cos x. Okay, because the sine x at the top and the bottom canceled out. Okay, the integral of cos, it's just sine. So we end up with sine x, the natural log of sine x, minus integral of cos. We said that was sine, so sine x, and don't forget your plus c. Okay, so that's another pretty straightforward thing. Maybe the only difficult thing here is picking what is your u and what is your dv. But like I said, if you got the natural log of something, doesn't matter what the other part is, differentiating the natural log is always easier than integrating the natural log. Okay, so just keep that in mind when you're looking through the problems. Okay, and for indefinite integrals, please remember to add your plus c. Okay, I don't want people losing marks because they don't put the plus c. Okay, any questions on this one?
Yeah, please repeat it.
Okay, sure, can do that. So we're going through 4.3 again. 4.3, we have the integral of cos x, the natural log of sine x dx. Okay, like I said before, it's always easier to differentiate the natural log. So u is equal to the natural log of sine x. It's in blue, and then everything else is going to be dv. So dv is going to be cos x dx. We now need to differentiate this. So we use the chain rule. The derivative of the natural log of sine x is going to be 1 over sine x times the derivative of sine x, which is cos. So we have cos x over sine x dx. Next, we need to integrate dv. So we get v is equal to sine x. Okay, that's just from integrating cos. Good, now we've got all four of those. We can then substitute into our integration by parts formula. So the integral of u dv is equal to uv minus the integral v du. Okay, it's always that, never changes. So the integral of cos x, the natural log of sine x dx is equal to u times v. So u times v, that's going to be sine x, the natural log of sine x, minus the integral v du is going to be sine x times, let's say times, cos x over sine x dx. Now we see that we've got a sine x in the numerator, sine x in the denominator, that cancels and that cancels. So we're left with sine x, the natural log of sine x, minus the integral of cos x dx. Okay, well, that's easy to do. What's the integral of cos? That's going to be sine. So we end up with sine x, the natural log of sine x, minus sine x plus c. Don't forget your plus c. Okay, so it's an indefinite integral. You always need your plus c at the end. Okay, is that all right now?
Yes, sir. Yes, sir.
Oh, okay. Awesome. Okay, so that's it for the test questions. That's it for the practice test 2. Do you have any questions for the real test 2 that's coming up? Okay, anything you're still stuck with? Okay, so I will post the homework problems for today on the WhatsApp group. This will be your last chance to get those bonus marks. So please give them a go and you can get some bonus marks for your test. And then tomorrow morning, the tutors will be available from 8:30 until 10:30. So please just join whichever group suits you best. And then ask your questions if you need to. And then the test will be written from 10:30 until 12. Okay. I will see you in the tutorial session tomorrow. Okay, so any last questions you got, please just ask them there. Or if you have questions later today, please let me know on the WhatsApp group. Okay, and give those homework problems a try. Okay, it's really good to get those bonus marks now, before you see the test. Okay, but I will upload those shortly. Okay, any questions before we go? Okay, cool. I'll see you tomorrow in the tutorial. Bye, everyone, and good luck with your last bit of revision.